Alright, so lesson 3.2 video 3 starts out with example 6, and it wants us to sketch the graph of this function here. Alright, well, let's talk about how we can set this up. So we're going to make a table, but I don't know how to take log base 3 of anything. But I do know that log base 3 of x, or y equals log base 3 of x, is the same thing if I wrote log base 3 of x equals y. And I know from there that I can set this up in exponential form. So knowing that my base is 3, my b to the y, my y is y, equals my x, which is x. Now this looks a little different. Looks similar to what we did in 3.1, but a little bit different because this time we're setting it equal to x instead of equal to y. So when I go to create myself a table here, I'm actually going to pick numbers for y so I can plug them in and solve for x. And so we're going to pick our favorite numbers, -2, -1, 0, 1, and 2. And this time we're going to plug them in for x. So I have 3 to the -2, 3 to the -1, just like what we did in 3.1. So 3 to the 0, 3 to the first, and 3 squared. And then we're just going to graph them. Now also though, remember that logarithms have a vertical asymptote at x equals 0. So we're going to come over here, and if you printed out the PowerPoints, I put a graph on there, I believe. At least I'm seeing one on mine. And so all you have to do is draw your x and your y axis. Now I'm going to graph my vertical asymptote at x equals 0. And so I'm hoping you can see this. So let me darken it a little bit here to make sure you can see my vertical asymptote, and being a little dramatic here with it, making it pretty dark. I'll draw above and below it just a little bit there. Alright, so there's my vertical asymptote, and I'm going to plot my points. I almost didn't make it there, but I got them all. And then remember, your graph continues, but you're not going to touch that vertical asymptote, so do your best not to let it run into it. And so there's our graph for log base 3 parent function. Now just like when we did the exponentials, there wasn't just one parent function because your base would change on them. Same thing here. But this is how you do it. If it was log base 2 of x, so let's say that I'm just a what if thing. So if I wanted to graph y equals log base 2 of x, then I would do 2 to the y equals x. And therefore, I would use the same y values. I would plug them in and get different x values. That's the only difference, okay? Alright, so knowing that, let's talk about some properties of logarithms because that's what it has next. Alright, so I'm just going to stay on this slide. So the properties of logarithms, it's just really comparing them with the exponentials, which we had already talked about. So remember with an exponential, we said that the domain was -infinity to infinity, and the range was 0 to infinity. And we said with logarithms, it was the opposite. So we said with logs, our domain is 0 to infinity, and our range is -infinity to infinity. With exponentials, the y-intercept is 1, and there's no x-intercept. Well, x and y switch for their inverse, which just happens to be a log. So there's going to be no y-intercept, and the x-intercept is at 1. With exponential functions, the x-axis was a horizontal asymptote, so we said we had a horizontal asymptote at y equals 0, which is the x-axis. And with logs, we have a vertical asymptote at x equals 0, which is the y-axis. So you can tell x and y on everything switch because exponential and logarithms are inverses. Alright, we also know the one-to-one property. So for exponentials, we know if we have b to the u equals b to the v, that means that u has to equal v. Well, the same idea with exponentials. If we have log base b of u equals log base b of v, as long as your log bases are the same, they cancel, and therefore u has to equal v. Also, for exponentials, it said that if the base is greater than 1, then the function would be increasing. Sorry, that's a kind of messed up looking greater than symbol. So our function would be increasing. And if it's between 0 and 1, it was going to be decreasing. And the same thing though with logarithms, it's going to be exactly the same. So if our, because we're talking about increasing and decreasing with logarithms, if our base, oops, what did I use for a base on the other? I used b, yeah. Just making sure. So if our base is greater than 1, it's still going to be increasing. If our base is between 0 and 1, then we're going to see that our function is decreasing. Alright, and then if you flip through, it just shows you, if you look through the PowerPoint there, it just shows you some graphs and what their bases are and whether it's increasing or decreasing. And so I'm going to go ahead, I'm looking at the time on this video, it's at like 7 minutes already, so I'm going to go ahead and stop here, and then we'll start up on video 4.